Ever imagine a world where even mentioning a function call in programming got everyone riled up? It's wild to think about that kind of shift. But that's what we're diving into today with Grady Booch. He's a legend in software development.
Yeah, a legend. You probably know him from UML, that visual language for software design.
Hmm.
But he's done way more than that. The guy's been building software since like the days of punch cards.
Yeah.
He's seen everything from object-oriented programming to, well, the whole AI revolution that's happening now.
And we're lucky enough to have some serious wisdom to unpack from him.
Right. He did this awesome interview on the Software Engineering Daily podcast, and we've got some fascinating excerpts here, ready to dig into what they mean for anyone who's interested in the tech that's shaping our world, basically.
So he starts off by talking about these golden ages of software engineering. And it's interesting how he sees two distinct periods. Each one is like a fundamental change in how we approach, how we think about building software.
Yeah, totally.
The first golden age, he says, was all about algorithmic languages, like Fortran and COBOL, for example. Huge, huge systems, right? I can practically hear those old mainframes whirring away.
Exactly. Monolithic systems. So it was all about figuring out ways to wrangle these increasingly massive systems that were built with these languages. But, as they grew, it became pretty clear that just using algorithms, pure algorithms, had its limits.
And that's where the second golden age comes in.
Right.
The rise of distributed systems, think the early ARPANET, that really forced developers to think differently because all of a sudden software had to work across, multiple computers, leading to a whole bunch of new challenges.
And new solutions, of course.
Mm.
And what's really interesting here? Booch, he points out that these breakthroughs, especially with distributed systems, a lot of them came from, military and defense needs. And the way he puts it is, all of modern computing was woven on a loom of sorrow. Kind of makes you think, doesn't it?
It's a powerful image for sure. It makes you think about, the roots of the technology we just, take for granted every day.
Totally. And right in the middle of this whole shift toward distributed computing, Booch, he was developing his own revolutionary approach to software design, the Booch Method.
This was a big deal. Instead of focusing on algorithms as like the building blocks of software, he's the one who brought in the concept of objects and classes, combining data and processes into these modular units, a total game changer.
Absolutely. A complete paradigm shift. It's crazy to think about it now, but back then, even the idea of a subroutine, what we call a function call today, that was controversial.
Wait, really? Why would something so basic be controversial?
Well, some people argue that it was inefficient. Like adding extra steps for the computer to go through. Imagine if that idea had won out.
It's mind-boggling. It just shows you how far software development has come, right? And how people like Booch, they've really shaped how we even think about writing code.
Totally. And the Booch method, that was just the start. Around the same time, other object-oriented methods were popping up. It became like some people called the method wars. Sounds intense, right? Different camps were fiercely advocating for their way of doing things.
That reminds me of the early days of the internet, when you had all those different browser technologies battling it out to be the top dog.
That's a good analogy.
Mm-hmm.
And just like the internet, it needed standards to thrive, right? Object-oriented programming needed that too. And that's where UML comes in.
UML, the Unified Modeling Language. Yeah, I remember wrestling with that in my computer science classes. A powerful tool, but it can be intimidating.
Definitely. And it's important to remember that Booch, he didn't create UML all by himself. He worked with, James Rumbaugh and Ivar Jacobson. Each of them, they had their own methodologies that were really influential.
Those are some heavy hitters in the software world, so they came together to create UML.
That's right. They wanted to bring all their different approaches together into one visual language that, the whole industry could use.
And they did it. That's a pretty big accomplishment, especially in tech where, strong personalities are kind of the norm.
For sure. And, Booch, he's very clear about what UML was meant for. It was supposed to be a visual language to help us think about and visualize and document software. Not, and this is important, not a programming language itself.
So then why does it sometimes have let's say, a mixed reputation? What happened?
Well, Booch thinks the decline started when people tried to make UML into a programming language. It got too complex, and I kind of missed the point of what it was originally supposed to do.
So trying to force a tool to do something it wasn't built for, that rarely ends well. But then that makes me wonder, if software architecture is always changing and, tools like UML are being questioned, what does that mean for the software architect? Like, what does that role even look like now?
That's a great question, and it's something Booch talks about directly. He's noticed a shift in the role of the software architect as the industry has matured. A lot of the architectural decisions, they're already baked into the frameworks and platforms that developers use these days. Things like cloud services, messaging systems, all that.
So does that mean software architecture is like a dying art? If so many of the decisions are already made, what's left for the architect to do?
Not at all. It's more like it's evolved. Booch says it's become less about designing every single detail from scratch and more about understanding what it means when you choose certain technologies, the bigger picture. It's about making decisions that have, well, real economic and long-term consequences.
So the software architect is more like a conductor leading an orchestra, blending these pre-existing components into something, harmonious. And that takes deep knowledge, right? Knowing the components inside and out and the trade-offs you make when you choose one over another.
I like that analogy, yeah, like a conductor. And, in the middle of all this change, there's one challenge that Booch believes will probably never go away: migrating software systems.
Ah, legacy systems. It feels like every company out there is wrestling with this, updating old code as technology keeps changing and business needs change, and it's a beast of a problem.
Oh, for sure. And it just gets harder the older the system. And Booch, he makes this really insightful point. He says, the code is the truth, but not the whole truth. What do you think he means by that?
That's interesting. What does he mean by that?
Well, he's saying that, yeah, the code tells you what a system does, but it doesn't always tell you the whole story of why it was designed the way it was. Those crucial design decisions and, well, the thinking behind them, they can get lost over time, especially if, the documentation is bad or the original developers aren't around anymore.
So you're left with this code that works, but you don't really understand why it works the way it does.
Exactly. It's like trying to solve a puzzle when half the pieces are missing. No wonder migrations are such a headache.
Totally. And as systems age, the problem just gets worse. The original developers, well, they might retire. Or, as Booch rather bluntly puts it, die, taking all that knowledge with them.
It's a little morbid, but, he's making a point.
Yeah, he's not sugarcoating it. That knowledge, it's valuable, and once it's gone, it's almost impossible to get back.
So it underscores how important the role of the software architect is. They have to think about the long term. It's not just building for today. It's about making sure that system can be maintained and adapted and ultimately, migrated to new technologies down the road.
It's a massive responsibility for sure, but a fascinating challenge too, right? And speaking of challenges, let's shift gears a bit and talk about something that's on everyone's mind these days, AI, especially those large language models, the LLMs.
This is where Booch's experience really shines. He's been involved with AI for decades. He even documented the architecture of IBM's Watson, the one that played Jeopardy. He's been deep in the world of cognitive systems. So his understanding, it goes way beyond, the current hype.
So what does he think about all this? I mean, AI is everywhere now. What's his take on it? Especially LLMs.
Well, he's not one to get carried away by the hype. He sees the potential, for sure. But he's also cautious.
Is he one of those people who's, worried about AI taking over the world? I gotta admit, some of those sci-fi scenarios can be a little unnerving.
His concerns are a bit deeper than that. He's definitely impressed by what LLMs can do, but he's not convinced that they actually understand the information they're processing, like really understand.
Okay, let's unpack that a bit. What does he mean by understand? Like, what's he getting at?
He uses these really interesting terms to describe them. He calls them unreliable narrators and stochastic parrots. Basically, he's saying that even though they can generate text that seems really intelligent, even hold conversations that seem coherent, they're essentially mimicking human language without really grasping the meaning behind it.
So it's more like they're sophisticated pattern matching machines. They can pull out facts and spit out information, but they don't actually get what they're saying.
Exactly. And this is where his background as a software architect comes in. He argues that simply making LLMs bigger, scaling them up, feeding them more and more data, that's not going to magically lead to true artificial general intelligence, or AGI.
So if bigger isn't better, what's the missing piece? What's the key to getting from these really impressive language models to, well, true AI?
This is where he brings in the concept of embodiment. He believes that truly intelligent systems, they need to be able to interact with and learn from the physical world, like humans do.
Okay, so instead of just living in this, digital world of data and algorithms, AI needs to have a body, sensors, the ability to actually move around and do things in the real world to, really understand.
Right. He compares it to his work with NASA, where he was involved in developing software for Robonaut 2. That was a humanoid robot designed to work with the astronauts on the International Space Station.
Wait, hold on. Did you say Booch helped design software for a robot astronaut? That's incredible.
Yeah, it was. And that experience had a huge influence on his thinking about AI. He realized that if you want a robot to be useful in a complex environment like space, you can't just pre-program it with every possible instruction.
Right. It needs to be able to adapt, learn from what's happening around it, make decisions on the fly, just like a human astronaut would.
Exactly. And that requires a different kind of software architecture, something that uses neural networks, symbolic reasoning, and most importantly, feedback from the real world, from sensors and interactions.
So it's a much more like holistic approach to AI, right? It's about combining the power of data with the ability to, reason and act in the world.
Exactly. And it shows why just throwing more data at an LLM isn't enough to create true intelligence. There's a difference between processing information and actually understanding the world and being able to interact with it.
Now, thinking about this whole concept of embodiment and just how complex these AI systems are, it brings me back to that question we were talking about earlier. If we want a UML for AI, where do we even begin? How can we represent these embodied systems in a way that makes sense?
That's a great question, and it's a huge design challenge. We need a way to show not just the algorithms and data structures, but also how information flows between the AI, its physical body, and the environment. It's a lot.
So we need to go beyond those traditional boxes and arrows of a UML diagram. We need to capture how dynamic these AI systems are, how they interact with the world.
Exactly. And I think this challenge of, how to represent AI visually, it's connected to another point Booch makes in his interview, the shift from these monolithic software systems to, distributed ones.
Ooh, that's an interesting connection. Can you say more about that?
He draws a parallel between the rise of distributed systems and the rise of LLMs, the ones we're talking about. Both of them represent a change, a fundamental change in how we think about software, how we build it.
So with distributed systems, we went from those huge mainframes, the ones that did everything, to networks of computers, all connected, each with its own specific job.
Right. And with LLMs, we're seeing a similar kind of shift away from rule-based systems, the ones that follow instructions, towards systems that learn from massive amounts of data. They're making decisions based on patterns, probabilities.
But like Booch says, both transitions, they led to a period of, uncertainty experimentation. It took time to figure out how to design and build and manage these new types of systems.
That's right. With distributed systems, it took time to figure out how to deal with latency, how to keep everything synchronized, how to make them fault tolerant across a network, things like that.
And with LLMs, we're still working all that out. How to manage their unpredictability, how to make sure their outputs are accurate, how to make sure they're not biased, and of course, how to integrate them safely and ethically into our systems.
It's definitely a journey.
Mm-hmm.
And Booch, with his deep understanding of the software industry, reminds us that these kinds of big shifts, they take time. There's no overnight solution.
It's about embracing the challenge,
Yeah.
experimenting, learning, and adapting as you go. And speaking of learning, I want to touch on something else Booch talked about. His advice for all the new software engineers who are coming into the field at such an exciting, but maybe also intimidating time.
Yes. His message is so positive. He's telling these new developers, don't be afraid of AI. Don't worry about it taking your job. Instead, see it as a chance to learn new skills and explore amazing possibilities.
It's good to hear that perspective because it's easy to get caught up in all the fear about job displacement.
Absolutely. He sees it as an opportunity,
Hmm.
a chance to expand what we can do to work with AI to solve bigger and more interesting problems.
Mm-hmm.
He really stresses the importance of continuous learning,
Hmm.
staying curious, staying adaptable in a field that's always changing.
And he also says, have fun, which, let's be honest, is something we sometimes forget in the tech world. We get so focused on the details, we forget to enjoy the creative process, the discovery.
He's a good reminder that passion and joy are essential ingredients for real innovation.
Well, on that note, I think we've covered a lot of ground in this first part of our deep dive. From the evolution of software engineering to, the crazy possibilities and challenges of AI, it's been quite a ride.
It has. But we're not done yet. Join us next time as we keep going with Grady Booch's insights. We'll be exploring his thoughts on the quest for true AI, the future of software architecture, and all the ethical considerations we have to think about as we enter this new world of intelligent systems.
There's so much more to come. Welcome back to our deep dive with Grady Booch.
We left off last time with a pretty mind-blowing question.
Mm.
What would a UML for AI actually look like? Like, how could we even map out how complex these systems are visually?
Yeah, it's a big question. It shows just how hard it is for us to even grasp these increasingly sophisticated AI systems. And the more they become part of our lives, well, we can't just treat them like a black box, right? We have to be able to, see how they work, how they make decisions.
And Booch is wrestling with that challenge himself. He's even turned to studying, get this, the architecture of the human brain, looking for, inspiration and ideas. I find that pretty fascinating.
That's so Booch, right? Thinking outside the box, finding insights in unexpected places. But before we go too deep into AI UMLs, I want to go back to something you mentioned earlier. Booch's perspective on LLMs. He's cautious about them.
Right, he is. He sees what they can do, of course, but he also calls them unreliable narrators and stochastic parrots. He's saying they lack true understanding.
Yeah, those are some colorful descriptions for sure.
Yeah.
But they might leave some people scratching their heads. Can you break it down a little? What's he really getting at?
Basically, he's pointing out that while LLMs can generate text that sounds incredibly human, even have these conversations that seem, coherent, they don't actually understand the information they're processing. Not the way we do.
So it's more like they're just really good at mimicking human language. They can pull info from these massive data sets, but without actually getting what it all means.
Exactly. It's like, think of a parrot repeating phrases it's heard, but not really comprehending what those phrases actually mean. And this is where Booch's background as a software architect comes in. He argues that just scaling up LLMs, making them bigger, feeding them more data, that's not going to magically give us AGI, true artificial general intelligence.
So if bigger isn't better, what's the secret ingredient then? How do we bridge that gap? What does he think is the key to moving from these impressive language models to real intelligence?
He keeps coming back to this idea of embodiment. To reach their full potential, he argues that AI systems need to be able to interact with and learn from the real physical world, not just the digital one, just like, we do.
So instead of living purely in the world of data and algorithms, AI needs a physical body, sensors, the ability to act in the world, to get feedback from its surroundings.
Exactly. And he brings up his work with NASA, where he was developing software for Robonaut 2, a humanoid robot designed to help astronauts on the International Space Station.
Hold on. Did you just say that Booch helped design software for a robot astronaut? Seriously, that sounds like something out of a movie.
It is pretty amazing.
Yeah.
And it really shaped his thinking about AI. He realized that to be truly helpful in an environment like space, a robot can't just rely on pre-programmed instructions. It needs to be able to adapt to what's happening, learn from its surroundings, make decisions on the fly, just like, a human astronaut would.
Makes sense. I mean, you can't program a robot for every possible situation, especially in space.
Right. And that kind of flexibility, it needs a different kind of software architecture. One that uses neural networks, symbolic reasoning, and crucially, feedback from the real world through sensors and interactions.
So a much more holistic approach to AI. It's about combining, data-driven learning with the ability to actually reason and act in the world based on what it senses.
That's a great way to put it. And it shows why just throwing more data at an LLM isn't enough for true intelligence. There's a fundamental difference between just processing information and truly understanding the world, being able to interact with it.
Now, this whole concept of embodiment and the sheer complexity of these AI systems, it brings us back to the UML question. If we're aiming for a UML for AI, how do we even start to represent that?
It's a massive design challenge.
Yeah.
How do we show not only the algorithms and data structures, but also how information flows between the AI, its physical body, and the environment? It's a lot.
So we need to move beyond the traditional boxes and arrows of a UML diagram. We need to find a way to show how dynamic these AI systems are, how they're constantly interacting.
Exactly. And I think this challenge of representing AI visually, it actually connects to another point that Booch brought up. The shift from monolithic software systems to distributed ones.
That's interesting. Can you connect those two ideas a bit more?
Well, he makes this analogy between, the rise of distributed systems and the rise of these LLMs that we're talking about. They both represent a fundamental shift in how we approach and build software.
So with distributed systems, we moved away from those giant mainframe computers that did everything and went toward networks of computers, all connected, each with its own job.
Right. And with LLMs, we're seeing a similar shift. Away from systems that are based on rules and instructions and towards systems that learn from massive amounts of data, making decisions based on patterns and probabilities.
But as Booch points out, both transitions, they brought a period of, well, a lot of uncertainty and experimentation. It took time to figure out the best ways to design, build, and manage these new kinds of systems.
Absolutely. With distributed systems, figuring out how to handle things like latency, synchronization, fault tolerance across a network, that took time and effort.
And similarly, with LLMs, we're still figuring it all out. How to manage their unpredictable nature, make sure their outputs are accurate and unbiased, and of course, how to integrate them into our systems safely and ethically.
It's definitely an ongoing process. And Booch, with his long view of the software industry, he reminds us that these kinds of big changes, they take time. There's no quick fix.
It's about embracing the challenge, the uncertainty, experimenting, learning as you go, and adapting along the way. Speaking of learning, I want to touch on something else Booch emphasized. His advice for all the new software engineers who are entering the field right now, it's such an exciting time, but maybe a little intimidating too.
Yes. His message is so positive and encouraging. He's telling these new developers, don't be afraid of AI, don't worry about it taking your job, see it as a chance to learn, to explore new skills and new possibilities.
It's refreshing, because it's easy to get caught up in the whole AI is going to take our jobs narrative. But he sees it as this incredible opportunity.
Exactly. A chance to, expand what we can do as software engineers, to work with AI, to solve bigger, more complex problems. He really stresses the importance of always learning, staying curious, being adaptable, especially in a field that's constantly changing.
And he also says, don't forget to have fun, which honestly is something that can get lost in the tech world. It's easy to get so serious and focused on the details that we forget to actually enjoy what we're doing.
He's right. Passion and joy, they're essential for innovation.
And speaking of facing challenges with curiosity and creativity, let's not forget that, that one challenge that Booch believes will always be with us, those legacy systems.
Ah, yes, those aging giants of code.
Oh.
It's a battle every software engineer has to fight at some point, right?
And earlier, you mentioned Booch has this really interesting way of looking at the problem. He said, the code is the truth, but not the whole truth. Can you explain what he means by that a little more?
Sure. He's pointing out that the code itself, it tells you what the system does, but it often doesn't tell you why it was designed that way in the first place. Critical design decisions, the reasons behind them, all that can get lost over time, especially if there isn't good documentation or if the original developers aren't around anymore.
It's like trying to understand, a historical event just by looking at some random objects without any context about, the politics, the social norms, the motivations of the people involved. You might get a glimpse of what happened, but you're missing the deeper meaning, the whole story.
Exactly. And that lack of context, it makes migrating those legacy systems incredibly difficult, risky even. You might be able to update the code itself, but if you don't really understand the original design choices, you might end up creating new problems or breaking things that were working.
It shows how important things like good documentation are. Knowledge sharing, maybe even having a more formal way to capture those architectural decisions and, the reasoning behind them. As our systems get more complex, and especially as AI becomes more integrated, this kind of archaeology of code, it's going to be even more important.
Absolutely. It reminds us that software engineering isn't just about writing code for today. It's also about understanding the history of our systems, how they evolved, the choices that were made, and what all that means for the future.
Well, we've covered a lot in the second part of our deep dive, haven't we? From AI embodiment to this quest for UML for AI and back to those legacy systems, plus the need for continuous learning. It's been a journey.
It really has. And we're not done yet. In the final part of our deep dive, we're going to explore Booch's thoughts on the future of software engineering, the ethical side of AI, and his amazing work documenting the architectures of real-world systems. It's like getting a backstage pass to see how it all works.
Sounds fascinating. Be sure to join us for the final part of our exploration into the mind of Grady Booch. There's so much more to discover. Welcome back. It's been quite a journey so far, wouldn't you say? Exploring the mind of Grady Booch. He's a true pioneer in the software world.
Absolutely. From punch cards and mainframes to, object-oriented programming and the mind-blowing possibilities of AI, it's amazing to see how much he's witnessed and, shaped over the years.
He has a really unique perspective on how software has evolved, right?
Right.
And all the challenges and, all the opportunities that lie ahead.
For sure. And in this last part of our deep dive, we're going to dig into some of his most, thought-provoking ideas, especially about the future of software engineering and all those kind of philosophical questions that AI brings up.
Yeah, and we'll touch on his work documenting real-world systems, the as-built architectures. It's like getting a sneak peek behind the scenes of like some of the most complex software out there.
It's fascinating. It shows just how many different architectural styles and approaches there are.
So to kick things off, I'm curious about his overall view of the future of software engineering. Given all the changes we've talked about, AI, the increasing complexity of systems, what does he see coming down the line?
Well, he's actually incredibly optimistic. He sees software becoming even more integrated into our lives, impacting everything. How we work, how we connect with each other, how we tackle big problems like climate change and healthcare.
So software is going to keep eating the world, as they say, but hopefully in a good way.
Right. But he emphasizes that to get there, we need a new kind of software engineer, someone who's not only good at coding, but also comfortable with AI, able to think about systems as a whole, and really important, deeply aware of the ethical implications of their work.
That's a crucial point. It's not just about the technical skills anymore. It's about, well, understanding the bigger picture, the human impact, the societal implications of what we're creating. Which brings us back to AI. We talked about Booch's skepticism about just making LLMs bigger and bigger. So if that's not the answer, what does he see as the path to achieving true artificial general intelligence?
He keeps coming back to this concept of embodiment. He's convinced that for AI to reach its full potential, it needs to move beyond the digital world. Data and algorithms. It needs to be able to interact with the physical world just like we do.
So AI needs a body, sensors, the ability to actually take action and, receive feedback from its environment to really understand.
Exactly. And he brings up his work with NASA on that Robonaut project,
Yeah.
where they were building software for robots that could work with astronauts in the extreme environment of space.
That experience must have had a huge impact on how he thinks about AI. I mean, designing software for a robot astronaut.
It did. It really forced him to confront the limitations of traditional programming, the rule-based kind. Because to be helpful in a place like space, a robot has to be able to learn and adapt, not just blindly follow pre-programmed instructions.
Makes sense. Which, brings us back to that question we were wrestling with before. If embodiment is so important for true AI, how do we design and understand these kinds of systems? Is a UML for AI even possible?
It's something Booch has been exploring. He's been experimenting with different ways to visually represent AI architectures, trying to capture not just the data and algorithms, but also the flow of information between the AI, its physical body, and the environment. It's definitely a challenge.
A big one. But it sounds exciting, too.
Oh, for sure. And it shows how we need new tools, new ways of thinking to make sense of this new era of AI. And, beyond the technical stuff, Booch also talks about the deeper philosophical questions that AI raises.
Yeah, it gets pretty deep, right? What does it actually mean to create machines that can think and learn? What are the ethical considerations? How do we make sure AI is beneficial for humanity? Those questions go way beyond just software engineering.
He believes we need to approach these questions carefully,
Mm.
with humility and, a sense of responsibility. He sees the amazing potential of AI, but he's also very clear that it's up to us, humans, to make sure its development aligns with our values, with what's good for society.
It's a good reminder that ultimately we're not just building software, right? We're shaping the future.
We are. And that brings us to something I wanted to mention. His project documenting real-world systems, those as-built architectures. It's like he's created a library of software blueprints, showing how some of the most complex systems in the world are actually designed and built.
I love this project. It's like you get to peek behind the curtain, see how the magic happens. He's documented everything from Photoshop, the one everyone uses to edit images, to Wikipedia, that massive online encyclopedia, to AlphaFold, the AI system that's changing how we understand protein structures. It's amazing.
It really is. It's such a valuable resource for anyone who's interested in software architecture. You get to see all these different design patterns and solutions that you might not come across otherwise.
And it also highlights that there's no one right way to design a system. It all depends on what you're trying to achieve, the limitations you have, and the context of the project. And as AI becomes more common, I think this kind of architectural diversity, it's going to become even more important.
I think so, too. We need to draw inspiration from lots of different approaches to design AI systems that are, robust, ethical, and aligned with human values.
So much to learn and explore. It brings us back to one of Booch's key messages, that continuous learning is so important. Having a mindset of exploration, especially in a field that's, always changing.
He's a great example of a lifelong learner. And he encourages everyone, whether you're just starting out or you've been doing this for years, to approach software development with that same sense of curiosity, passion, and, a willingness to embrace what you don't know.
And he reminds us to have fun along the way. Remember why we got into this field in the first place. Well, on that note, I think it's time to wrap up our deep dive into the world of Grady Booch.
It's been an incredible journey, full of insights, challenges, and inspiration. He's a true visionary, and his thoughts on software, past, present, and future have given us a lot to think about.
To everyone listening, thanks for joining us on this deep dive. We hope you've learned something new and maybe rediscovered some of the wonder and excitement of software development.
And the amazing minds behind it. Keep exploring, keep learning, keep building amazing things. We'll see you next time.